Hi everyone. Let's talk about mediation analysis. Now, I'm going to make this pretty quick and dirty. This will be more of a live stream type format. Unfortunately, my video won't be showing anywhere on the screen. I'm still trying to figure out OBS. But anyways, this is an analysis that's relevant to a paper that I want to go over for the journal club. And this link was sent to me kindly by Dr. Holly White. She's a co-author on that paper, this 2006 paper. We'll get to that eventually in another video. But mediation analysis, there's this nice tutorial. I'll put the link to the site in the description if you want to follow along. And I'll be explaining everything at a relatively high level. In other words, this is not my expertise, and so I'll explain in terms that I believe are correct. But if you catch any issues, if you know more stats than I do, which is highly likely, then please leave a comment, and I'll be sure to acknowledge that. Okay, now mediation analysis. They go through this excellent example here, and they say, let's suppose that there have been studies that show that that higher grades predict higher happiness. So we have this relationship between grades and happiness. They've done some kind of significant testing and with well-controlled data sets. But let's say we come along and say, oh, well, I believe that there's an intermediate variable that's actually causing, not necessarily causing, but has an effect between grades and happiness, namely self-esteem. So the hypothesis would be, well, I believe that grades lead to high self-esteem, which in turn lead to greater happiness. The paper that I want to go over is the relationship between ADHD and inhibition. And what they do is, it's been known that across various metrics, people with ADHD, let's say, will perform better on different types of tasks involving divergent thinking, different memory tasks and such. Certain types, not all. Obviously, we all have issues with memory tasks, many of us. And the question was, well, does inhibition play a role? So they measured they did the same tests, but then also looked at how inhibition affected those things, and then they used mediation analysis to establish that yes, their inhibition does play a statistically significant role. Now, with all these things, we have to be careful about correlation versus causation. This type of analysis doesn't necessarily establish causation, so something to keep in mind as we go over this. Now, how do we analyze it? And hopefully as we go through this, by the end, you'll have a good sense of what it means for a variable to be a mediating variable. Okay, to analyze mediation, well, we're just going to go through this tutorial. And the Barrett and Kenny, this is a classic paper where all of this comes from. And that's what the bulk of this paper, this tutorial is about. But they also do a lot of significance testing. I'm not going to discuss that in detail anyways. The very high level, fast and loose idea of significance testing is if you get this number, this p-value, you can think of it as a probability of getting that data by chance. So if you have a very low p-value, then the probability you got the data by chance is very low, and so you have some statistically significant data. All right. Now this data comes from this site, and I'll just copy paste that into here, save that to the variable my data. I'm using R, obviously, and apologies for doing this in Windows. That's not my preferred OS for programming, but it'll do in a pinch. Okay, step 1, establish the relationship between X and Y, so between grades and happiness, say, or ADHD and whatever tasks you're looking at. And the way we do this is to look at to basically do a linear fit. So this is called a linear model. Linear because the variables have a linear dependence. And then there's two coefficients that we'll use some automated method to figure out. E is some kind of measurement error. We won't worry about this too much. What we'll worry about is B0 and B1 and whether or not they're significant. In particular, the B1 here. So what we do is we put the data into the linear model function in R, and that automatically takes care of all the fitting for us. And if we output the summary of that, we get all this information. And the important lines that I want to focus on are these two. Okay. And in particular, B1, the coefficient for x, this is, whatever value it is, we have a value, but more importantly, it is significant. That is, the probability of getting this value by chance is this low. And for the purposes for the data that we're working with, that is significant. Obviously, the p-value, whether or not something is significant, will depend on the study. Yeah, another thing to keep in mind if you move forward in this field and do these kinds of things. That's step one. Apparently, there's some controversy. I'm not going to worry about it. Moving on to step two. Now we establish the effect between x and the mediating variable. So we again do a linear fit between now a new coefficient b2 and b naught for that particular relationship. Okay, so let's do that. Okay, model.m, if we summarize it, we get this output, and we see that we have a fit. Moreover, the fit is significant. Okay, so that's that's the b2. So far so good. Next, and this is probably the most important part, we now include both m and x as the independent variables, and then establish how those two affect the dependent variable y. Okay, so this is still a linear fit. It's now multilinear regression because we have multiple variables, x and m, and we have to fit multiple, coefficient for each variable. So let's give that a shot. Summary. And this is very interesting now. So what happened is that we see an effect on m to y. It's a significant effect, as we can see by the probability here. But the effect from x to y disappeared. The probability is actually, it's pretty dang high. So after including the mediating variable into this linear model, the effect from x to y disappeared. And this is the hallmark of m being a mediating variable. In fact, we can say that it fully mediates between x and y. And it's possible now that, as a side note, the effect on x and y can still exist, but in a smaller magnitude. In that case, m would be a partial mediator between x and y. Okay? But that's the idea, is that you include both x and m as independent variables in this linear model, and the effect from x to y should diminish or disappear if you're very lucky. So yeah, there we go. And the statistical significance I mentioned, that's I won't go into that. It requires stuff about t-tests, understanding t-tests, which isn't horrible, but it's just more stuff that the intuitive description works well enough for all of this. Okay, so then they do more statistical testing to figure out more rigorously what happens. But there you go, pretty quick and dirty. And using this data set, which I believe it does answer this particular questions of grades, self-esteem, and happiness. Well, we've established that self-esteem is in fact a mediator between grades and happiness. Pretty neat. Okay, that's it. Thank you all very much. I'd like to shout out one person, Alden Bradford, a fellow mathematician who is currently a graduate student. Thank you so much for the donation on Buy Me a Coffee. If this was helpful to you, then please consider donating, but obviously never, please, ever feel obligated to donate to me, ever. I have an income. I'm not interested in making more through YouTube. So I'll leave it at that. Take care.